Did ancient civilizations harness the power of electricity millennia before modern science? A peculiar artifact discovered in Iraq suggests they might have. Could the Baghdad Battery, a simple clay jar containing copper and iron, truly be an ancient electric cell? The answer lies buried beneath layers of history, speculation, and scientific scrutiny. Welcome to the Midnight Files, where we delve into the unexplained mysteries that challenge our understanding of the past. Tonight, we investigate the Baghdad Battery, 2,000-year-old electricity. Our story begins in 1936 within the hallowed halls of the National Museum in Baghdad. Picture this, the dust-laden shelves crammed with millennia of Mesopotamian history, silent witnesses to empires risen and fallen. Wilhelm Koenig, an Austrian archaeologist, stood amidst this ancient clutter recently, appointed director of the museum's laboratory. Koenig, a man known for his meticulous attention to detail and his somewhat eccentric fascination with unorthodox archaeological theories, was meticulously cataloging the museum's vast collection. The air hung thick with the dry, earthy scent of ancient pottery and the faint aroma of preservatives used on excavated artifacts. He wasn't just looking at objects, he was attempting to piece together a narrative, a cohesive understanding of the cultures that birthed them. He was searching for connections, patterns, and anomalies that might rewrite the accepted history books. The museum itself, a relatively new institution at the time, was a repository of treasures unearthed from the Fertile Crescent, a region teeming with the remnants of some of the oldest civilizations on Earth. Excavations were rampant across the Iraqi landscape, constantly feeding the museum with a steady stream of newly discovered relics. It was in this atmosphere of constant discovery and scholarly debate that Koenig stumbled upon something truly perplexing. Tucked away amongst a collection of seemingly unremarkable pottery shards and miscellaneous objects was a group of three peculiar artifacts. These weren't grand statues or intricate jewelry. They were, to the untrained eye, rather unassuming. Each consisted of a terracotta jar, roughly 13 centimeters, about 5 inches in height. The clay, a dull yellowish-brown, was coarse and unglazed, suggesting a utilitarian purpose rather than an ornamental one. These jars, while not entirely identical, shared a common form, a slightly bulbous body tapering to a narrower neck. But it was what resided inside these seemingly ordinary vessels that piqued Koenig's interest. Each jar contained a copper cylinder, meticulously crafted from a rolled sheet of copper. This cylinder, approximately 9 centimeters long and 2.5 centimeters in diameter, was carefully placed inside the jar, leaving a small gap between its outer surface and the inner wall of the clay vessel. The bottom of the cylinder was capped with a copper disc soldered or somehow affixed to create a sealed compartment. And here's where the mystery deepened. Suspended within the copper cylinder, held in place by an asphalt stopper, was an iron rod. This rod, slightly thinner than the copper cylinder, ran down the central axis of the vessel, seemingly isolated from the copper, except perhaps at the very top, where it passed through the asphalt plug. The asphalt, a naturally occurring tar-like substance, acted as both a sealant and an insulator, preventing direct contact between the iron rod and the copper cylinder for the majority of their length. Koenig's initial reaction, as documented in his notes, was one of profound curiosity, mixed with cautious skepticism. He immediately recognized the potential implications. This wasn't just another piece of pottery. The arrangement of copper, iron, and the insulating asphalt suggested something far more intriguing, something potentially revolutionary. He meticulously documented his findings, sketching detailed diagrams and carefully noting the dimensions and materials of each component. He consulted with colleagues, presented his observations, and sought their opinions. The initial reaction from the academic world was predictably mixed. Some dismissed Koenig's theories as fanciful speculation, pointing to the lack of definitive evidence and the prevalence of other more conventional explanations for the object's existence. Others, however, were intrigued by the possibilities and cautiously encouraged further investigation. The prevailing theory at the time, and still a contender today, was that these jars were simply storage vessels for scrolls or other precious objects. The copper and iron components, according to this viewpoint, might have been remnants of some long-lost preservation method, perhaps, intended to protect the contents from decay or corrosion. The asphalt would have served to seal the jar, ensuring its contents remained undisturbed. However, Koenig wasn't convinced. He couldn't shake the feeling that there was something fundamentally different about these artifacts, something that defied conventional explanation. He meticulously researched ancient texts and archaeological reports, searching for any clues that might shed light on their true purpose. He knew that proving his theory would require more than just speculation. It would demand rigorous scientific testing and compelling evidence, and that testing would have to wait. The world was on the brink of war. Europe was descending into chaos, and the looming conflict would soon engulf the Middle East as well. Koenig, understandably, had to prioritize the safety and preservation of the museum's collection. The Baghdad Battery, along with countless other invaluable artifacts, was carefully packed away and stored in a secure location, awaiting a time when scholarly inquiry could resume. The question of whether these unassuming clay jars held the secret to ancient electricity would remain unanswered, shrouded in mystery for many years to come. The world had bigger problems to worry about. But the silence surrounding the Baghdad Battery wouldn't last forever. After the turmoil of World War II subsided, Wilhelm Koenig, undeterred by the initial skepticism, published his controversial theory in 1940. He proposed that these peculiar artifacts were in fact galvanic cells, ancient batteries capable of producing electricity. His paper, though initially met with considerable resistance, sparked a wave of renewed interest and ignited a debate that continues to this day. To understand the basis of Koenig's bold claim, we need to delve into the science behind the artifact and examine the experimental evidence that has been gathered over the decades. Let's start with the materials themselves. As we've established, the core components are a terracotta jar, a copper cylinder, an iron rod, and an asphalt stopper. The terracotta being a readily available and inexpensive material in ancient Mesopotamia is not particularly noteworthy in itself. However, the copper and iron present a far more compelling story. The copper cylinder, crafted from relatively pure copper sheeting, acts as the cathode, the positive electrode in the proposed battery. The composition of this copper has been analyzed in modern laboratories using techniques like X-ray fluorescence and mass spectrometry. These analyses have revealed that the copper, while not perfectly refined by modern standards, is remarkably pure, containing only trace amounts of other metals like lead or arsenic. This level of purity is significant because it allows for a more efficient flow of electrons, a crucial factor in generating electricity. The iron rod, on the other hand, serves as the anode, the negative electrode. Analysis of the iron rod reveals a similar story. It is relatively pure wrought iron, a common metal in the Parthian and Sasanian period. The asphalt, a naturally occurring mixture of hydrocarbons, acted as a crucial insulator, preventing direct contact between the copper and iron and thereby preventing a short circuit. Its role as a sealant is also vital, ensuring that any electrolyte solution added to the jar would be contained. Now, the critical question is, how could these materials, arranged in this specific configuration, generate electricity? The answer lies in the principles of electrochemistry. When two dissimilar metals, such as copper and iron, are immersed in an electrolyte A solution capable of conducting electricity, a chemical reaction occurs. The iron, being more reactive than copper, tends to lose electrons in a process called DO oxidation. These electrons flow through the electrolyte towards the copper, which acts as a catalyst for the reduction of hydrogen ions in the solution, completing the electrical circuit. This flow of electrons constitutes an electric current. But what electrolyte would the ancient Mesopotamians have used? This is where speculation comes into play, but several plausible candidates have been proposed. Koenig himself suggested that the jars might have been filled with an acidic solution, like vinegar or wine, both readily available in the region at the time. Other possibilities include citric acid from citrus fruits, although the presence of citrus in Mesopotamia during that period is debated. Grape juice, or even naturally occurring acidic spring water, could also have served as suitable electrolytes. To test Koenig's hypothesis, numerous scientists and researchers have attempted to replicate the Baghdad Battery under controlled laboratory conditions. One of the most famous and often cited experiments was conducted by Willard Gray in the 1970s, using a replica of the Baghdad Battery and filling it with a 5% solution of acetic acid. Gray was able to generate a voltage of approximately 0.5 volts. This voltage, while relatively small, is undeniably significant. It demonstrates that the configuration of the Baghdad Battery, when combined with a suitable electrolyte, is indeed capable of producing electricity. Other researchers, using different electrolytes such as copper sulfate or lemon juice, have reported voltages ranging from 0.8 to 2 volts. These voltages, while not enough to power modern appliances, could have been sufficient for various purposes in antiquity. One popular theory proposed by Egyptologist Arne Egebrecht suggests that the Baghdad Battery might have been used for electroplating, the process of coating one metal with a thin layer of another metal using electricity. Egebrecht demonstrated that a replica of the Baghdad Battery could successfully electroplate a thin layer of gold onto a silver object, a process that would have been highly valued for creating ornate jewelry and religious artifacts. He used a gold cyanide solution as the electrolyte. Another proposed application is electrotherapy, the use of electricity for medicinal purposes. While the evidence for this is purely speculative, some historians suggest that the mild electric current produced by the Baghdad Battery might have been used to relieve pain or stimulate muscle contractions. This aligns with certain ancient medical practices that involved the use of electric fish to treat ailments. Dating the Baghdad Battery is crucial to understanding its historical context and purpose. Unfortunately, directly dating the components of the battery is challenging. The terracotta jar itself can be dated using thermoluminescence dating, a method that measures the amount of radiation trapped within the clay. However, this method only provides an approximate age range and can be influenced by various factors. The original Baghdad batteries were found within a context that suggests they belong to the Parthian period, which spanned from roughly 250 BC to 25 AD. This dating is based on the surrounding artifacts found at the excavation site in Kujut Rabu near Baghdad and the overall archaeological context. However, more recent analyses suggest a possible Sasanian-era dating. This uncertainty highlights the need for further research and more precise dating methods. Despite the experimental evidence and the plausible applications, the Baghdad Battery remains a subject of intense debate. Critics point out the lack of direct evidence for its use as a battery, the absence of wires or other electrical components at the excavation site, and the possibility of alternative explanations for its function. They argue that the jars might have been used for storing scrolls, as suggested earlier, or for other unknown purposes. The asphalt seal, they argue, could have been used to prevent the contents from leaking or to protect them from moisture. Some skeptics even suggest that the arrangement of copper and iron was purely coincidental. However, proponents of the battery theory emphasize the remarkable correspondence between the artifact's design and the principles of electrochemistry. They argue that the absence of wires or other electrical components doesn't necessarily disprove the battery theory, as the ancient Mesopotamians might have used different methods of connecting and utilizing the electricity. Furthermore, they point to the lack of any other plausible explanation for the unique arrangement of copper, iron, and asphalt within the jars. The debate over the Baghdad Battery is likely to continue for many years to come. While the available evidence strongly suggests that it was indeed capable of generating electricity, the precise purpose and extent of its use remain shrouded in mystery. Was it used for electroplating, electrotherapy, or some other unknown application? Did the ancient Mesopotamians fully understand the principles of electricity, or was their discovery a result of accidental experimentation? These are questions that may never be fully answered, but the Baghdad Battery serves as a tantalizing reminder of the ingenuity and resourcefulness of ancient civilizations and the possibility that they possessed knowledge and technologies that have yet to be fully understood. The Baghdad Battery presents us with a complex puzzle, a tantalizing glimpse into the potential technological capabilities of an ancient civilization. But the path to understanding is fraught with challenges. One of the major issues plaguing the debate surrounding the Baghdad Battery is the scarcity of supporting evidence. While the artifact itself is undeniably intriguing, the lack of accompanying tools, wires, or other electrical components at the excavation site raises significant questions. If the Baghdad Battery was indeed used to generate electricity, where are the devices or tools that were powered by it? Where is the evidence of electroplating, workshops, or other applications that would have required a source of electricity? This absence of corroborating evidence leads many skeptics to propose alternative hypotheses for the Baghdad Battery's function. One of the most prominent of these is the scroll storage theory, which we've already touched upon. Proponents of this theory argue that the jars were simply used to store scrolls or other precious documents, with the copper cylinder and iron rod serving as a means of preservation. The asphalt seal in this view would have protected the contents from moisture and decay. While this explanation seems plausible on the surface, it fails to adequately address the specific arrangement of the copper and iron and the insulating properties of the asphalt. Why use two different metals? Why isolate them with asphalt? And why this specific configuration within the jar? These details seem oddly specific for simple storage. Another alternative hypothesis suggests that the jars might have been used for storing sacred liquids or potions, perhaps as part of religious rituals or alchemical experiments. The copper and iron in this scenario could have been believed to possess magical properties or to enhance the potency of the liquid. While this explanation aligns with the known prevalence of religious and magical practices in ancient Mesopotamia, it remains highly speculative and lacks any concrete evidence. It's important to note that the artifact was discovered in an area where pagan shrines and residences existed, but not in a temple or consecrated space. Then there's the condenser hypothesis. While less prevalent, this theory suggests the device might have been used to store static electricity generated by other means, such as friction. However, the materials and construction are not ideally suited for a condenser, making this unlikely. The debate often boils down to interpreting the intention of the artifact's creators. Were they aiming to generate electricity, or was the resulting electrochemical reaction simply an unintended side effect of some other process? This leads us to the realm of out-of-place artifacts, or OPARTs, objects that appear to be too advanced for their purported time period. The Baghdad Battery is often cited as an example of an OPART, a piece of evidence suggesting that ancient civilizations possessed knowledge or technologies far beyond what is generally accepted by mainstream science. However, the concept of OPARTs is often met with skepticism by archaeologists and historians. They argue that many OPART claims are based on misinterpretations, exaggerations, or outright fabrications. They emphasize the importance of rigorous scientific analysis, contextual evidence, and critical thinking when evaluating such claims. In the case of the Baghdad Battery, it's crucial to avoid jumping to conclusions and to carefully consider all possible explanations before declaring it an undeniable example of ancient electrical technology. It's also important to remember that the term electricity in antiquity might have had a different meaning than it does today. Ancient civilizations may have observed and experimented with electrical phenomena without fully understanding the underlying principles. The Greeks, for example, were familiar with static electricity, having observed that amber, when rubbed, could attract lightweight objects. Thales of Miletus, a philosopher who lived in the 6th century BC, even wrote about this phenomenon. However, there is no evidence that the Greeks or any other ancient civilization developed a practical application for static electricity. The Baghdad Battery invites comparisons to other historical cases and legends that hint at the possibility of advanced ancient technologies. One example is the Antikythera mechanism, an ancient Greek analog computer discovered in a shipwreck off the coast of the Greek island of Antikythera. This incredibly complex device, dating back to the 2nd century BC, was used to predict astronomical events such as eclipses and planetary positions. Its level of sophistication is astounding, and it demonstrates the advanced engineering skills of the ancient Greeks. Another intriguing example is the legend of the Vimanas, flying machines described in ancient Indian texts such as the Mahabharata and the Ramayana. These texts describe Vimanas as being capable of flying at great speeds and engaging in aerial warfare. While there is no physical evidence to support the existence of Vimanas, the detailed descriptions in the ancient texts have sparked much speculation and debate. These examples, along with the Baghdad Battery, highlight the enduring fascination with the possibility of lost technologies and forgotten knowledge. They remind us that our understanding of the past is constantly evolving and that there may be many more surprises waiting to be uncovered. However, it's essential to approach these claims with a healthy dose of skepticism. Extraordinary claims require extraordinary evidence, and it's crucial to avoid romanticizing the past or projecting our modern understanding of technology onto ancient civilizations. The Baghdad Battery, like the Antikythera mechanism and the Vimanas, remains a mystery, a challenge to our understanding of history, and a testament to the enduring power of human curiosity. While it is tempting to imagine ancient Mesopotamians using electricity to power lights or operate advanced machinery, the reality is likely far more nuanced and complex. The true purpose of the Baghdad Battery may never be fully known, but its existence serves as a valuable reminder that the past is not always what it seems, and that there are still many secrets waiting to be unearthed. So what are we to make of the Baghdad Battery? After sifting through the historical accounts, the scientific experiments, and the fervent debates, the mystery persists. We've explored the possibility of it being an ancient battery capable of generating a small electrical current, potentially used for electroplating or even rudimentary electrotherapy. We've also examined alternative theories: a container for sacred scrolls, a vessel for alchemical concoctions, a tool for an unknown purpose. The truth, as is so often the case with history, likely lies somewhere in the nuanced intersection of these possibilities. Regardless of its precise function, the Baghdad Battery carries immense historical significance. It challenges our linear perception of technological progress, forcing us to confront the possibility that ancient civilizations possessed knowledge and skills that have been either lost or underestimated. It serves as a potent reminder that innovation isn't a solely modern phenomenon. Ingenuity and curiosity have been driving forces of human civilization for millennia. The artifacts urge us to look beyond the grand narratives of kings and empires and to delve into the everyday lives of ordinary people who may have been experimenting with technologies that were far ahead of their time. The Baghdad Battery also underscores the importance of interdisciplinary approaches to understanding the past. Archaeology, chemistry, history, and engineering all contribute vital pieces to the puzzle. By combining these diverse perspectives, we can gain a richer and more nuanced appreciation of the complexities of ancient civilization. It exemplifies the importance of keeping an open mind, of questioning accepted wisdom, and of embracing the unknown. The story of the Baghdad Battery reminds us that the past is not a static entity. It's a dynamic and ever-evolving field of inquiry, constantly being reshaped by new discoveries and new interpretations. Ultimately, the message of the Baghdad Battery is one of both caution and wonder. Caution, because it's crucial to avoid romanticizing the past or exaggerating the capabilities of ancient civilizations. Wonder, because it highlights the remarkable potential of human ingenuity and the enduring allure of the unknown. It encourages us to explore the mysteries of the past with a critical eye, but also with a sense of open-minded curiosity. Whether it was a sophisticated electrical device or simply a cleverly designed storage vessel, the Baghdad Battery continues to spark our imagination and challenge our understanding of history. It is a testament to the power of human innovation, regardless of the era in which it originated, and a reminder that even the simplest objects can hold profound secrets waiting to be unlocked. And it reminds us to never assume we know the whole story, because the past is full of surprises. Please like and subscribe, and I'll see you in the next video. Thank you.